project is, does the health of the Little Miami River deteriorate as it flows downstream? I chose this project because I've always been interested in the Little Miami River and I wanted to learn more about it. So I started thinking, how healthy is the river? Is it healthy from top to bottom? I started to research how I could measure the health of a river, and I kept coming across the use of macroinvertebrates. I found out that different types of macroinvertebrates have different tolerance levels to aquatic pollution. For example, stoneflies and mayflies, this is a mayfly, are sensitive, group 1. Netsmen and caddisflies are somewhat sensitive, group 2, and leeches are tolerant, group 3, the worst macroinvertebrates you can find in rivers. You can calculate a pollution tolerance index score based on the presence or absence of certain insects. My hypothesis for the experiment is if sewage and chemical inflows increase due to urbanization as the Little Miami flows downstream towards the Ohio River, then fewer sensitive group 1 aquatic insects will be present, indicating that the water quality is inferior. At first, I thought this project was going to be pretty simple. All you have to do is sample the insects, count them, and then calculate the pollution tolerance index score. However, I found out that it was going to be harder to get good and precise results because there are many things in my experiment that could skew the results. My independent variable is the specific sampling site along the river. I chose one to the north, one in the middle, and one to the south. My dependent variable relates to the tolerance levels of the aquatic insects that are collected at the sites. The insects differ in tolerance to pollution. My first control variable is to sample the insects on the same day to make sure that the water conditions were the same. Second, I sampled at the same habitat type. I chose riffle sections of the water because there are most insects in that area and it was most easy to access. Third, my sampling techniques and sortings were the same at all 3 sites. After selecting the best sites, it was time to start my sampling. I had lots of materials to bring, including a net and a thermometer and tweezers, to name a few. In order to perform this experiment, you have to drive to the site and set up. I would do water chemistry tests to see if the aquatic insects could survive in the river. Then I would sample the insects. I would use a net and kick up the bottom substrate of the river and then let the aquatic insects float down into the net. I would then sort through the insects using tweezers and record the numbers of each. After all my data was recorded, I calculated all of the pollution tolerance index values. It was pretty simple. You take the total number of group 1 insects and multiply it by 3. You take the total number of group 2 insects and multiply it by 2. And you take the total number of group 3 insects and multiply it by 1. That is how you got the pollution tolerance index values. And using that information, 23 or more indicated excellent, 17 to 22 indicated good, 11 to 16 indicated fair, and 10 or less indicated poor. And the pollution tolerance index rating key helped me find the average PTI score. After all my scores are calculated, the macroinvertebrate sampling indicated a pollution tolerance index score of 24.25 at Site 1, 21.75 at Site 2, and 17.5 at Site 3. In fact, about 57% of all the aquatic insects I collected at Site 1 were Group 1 sensitive aquatic insects. Therefore, the overall results show that the water quality is best at Site 1 and worst at Site 3. It is reasonable to conclude that urbanization impacts the water quality as the river flows south. If I were to extend this project, I would sample at additional sites along the river. I would also like to sample at a different time of year to see if I would collect anything different. It is also important to say that although the water quality deteriorates as it flows south, The water quality is still considered to be good at all 3 sites. Thank you. Any questions?
Yes. What are the main urbanization issues that you found, and what do you think is affecting the river the most as it flows downstream?
As the river flows downstream, I think, as you said, urbanization is one of the main reasons. And I think along with that, sewage runoff and lawn chemicals, for example, are some of the main urbanization issues, especially down by Site 3, because that is more of an urban area with more urbanization and more people. And
Okay.
Site 1 is in a better rural area.
Okay. Can you explain more about the PTI score? How do you get it again? You multiply and then you add up the numbers. Is that how you get the score, or how does that work?
Yes, I used for one of my references, it was a Lamota pamphlet, and it pretty much taught me how to find the PTI score. So technically, there was this sheet, and I would calculate how many insects I found of each type. So for example, maybe I found 15 stoneflies. So then I would multiply the total number of that whole group, and I would multiply it by 3 if it's in the sensitive group. If it's in the tolerant group, for example, I'd only multiply it by 1 for that site.
Okay, so I assume that the hardest thing for you to do was to learn how to identify some of these insects. Is that
Yes.
right? Like looking at them all and trying to separate them out and identifying what is what, because they all kind of look the same at some points. But
Yes, I
okay.
used one of my references. It pretty much helped me while I was sorting through the insects. I would look at that sheet of paper to help me identify, because especially since the macroinvertebrates are small, it's hard to see and identify them. And when I first did this experiment, I realized that I had identified many insects wrong, but I later changed it and made the correct adjustments.
Okay. Is there anything else that you would do differently if you did this again?
Not much, except maybe, like I said, do this at a different time of year. I would like to do that because I did this around October, November, at winter time of year. And for example, if I did it in the spring, maybe around April or May, I would definitely find different aquatic insects, because at that time there are different aquatic insects in the river than there are in the winter time.
All right. Well, thanks so much.
Thank you.
Okay, bye.